to Data Garden. Thanks for checking out my video. I hope you're doing very well. Today's video is about dealing with missing values. Missing values are a very complicated problem because maybe if you have plenty of data, then you can just allow to discard them, but maybe you only have few data points and then it sort of becomes problematic and you want to try to find a way of maybe replacing the missing values with a value of some sort. Today we are first going into the more easy ways of dealing with missing values, and then in the follow-up video we will use some more, let's say, advanced machine learning type of solutions to deal with missing values. So let's get right into it and create a new R file using file, new file, R script. Alright, the data set that I want to use for this tutorial is the ozone data set that is included in the MLbench package. So we have to load two packages first before we get started. So let's use the command library, and the first one is MLbench. If you don't have this package, I highly recommend it. It's a package with data sets and functions to generate your own data, sort of for testing out machine learning. And yeah, I think it's excellent. And the second data set that we the second library that we need is dplyr for some simple data handling. Okay. Then let's load our data set using data and then in the brackets ozone, like this. And I'm going to press Command and Enter always to run my lines of code. And let's have a quick look at the data set here. See that it has 13 variables and that there are quite some missing values in almost all of the columns. So I think it's an excellent data set to work on for this particular problem of how to deal with missing values. Okay, so first we see a problem here, which is that the columns here don't have column names. And I think if we want to continue working with this data set for a bit, then it's good that we change that. So I'm first going to use the call names command to redefine the column names of the data set. So that will be call names and then in the brackets ozone. And we are going to define a vector with the names. And I have here used the help function to show the description of the data. So I'm going to orient myself with that for defining the names. But I'm not going to be super strict here because it's just a test exercise, of course. So the first column is the months. Then comma, the second column will be the day, the third one will be the weekday, oops, comma, then we have the, oops, forgot the quotation mark, ozone level, then we have the air pressure, if I see that correctly. Then we have the wind speed, then the humidity, then the temperature in one place. I'm going to call that temp 1, and then temp 2 for the second place. Then we have the inversion-based height. I'm going to call that inf_height. Then we have the pressure gradient. I have to admit I don't even know what that is, but it's not really relevant for the task at hand here. Then we have the inversion-based temperature. I'm going to call that inf_temp. And the visibility, finally. I'm going to call that just vis. Okay, going to run with Command and Enter. And now our data set already looks a bit better. So now in the first step, let's maybe show some descriptive statistics using the summary command. So that would be summary ozone. And now we see that for each of the columns we have here, I think in particularly important is the median and the mean. And we see how many NAs or missing values there are in each of the columns. And we find that in particular here is one column, the temperature for the second place for El Monte. There are 139 missing values. And with a total of 366 observations, that is really quite heavy. Okay, so, but now let's get into the methods that we can use to deal with missing values. The first one is, of course, to throw out all the observations that have missing values. Now, if you're only interested in some columns, then maybe what you can do is you can throw out only some columns that contain missing values, but keep others. So that would, or rather you could only throw out observations that have missing values in some columns, but not in others. And how you would do that simply with R-base functions would be that you define ozone as ozone, and then in square brackets you type is.na, which picks up the values that are missing, and you type ozone, and then you use the dollar operator. And for example, let's say we want to throw out only the observations that don't have an ozone reading, because that's what we want to predict, but we keep all the other ones. I think that would be a sensible approach, for example, since this is what we want to predict, like later in our machine learning problem. Then it sort of doesn't make sense to keep the observations that don't even have a reading here. And then after the first closing bracket, we still have to type a comma because we want to keep all of the columns. So I'm going to press Command and Enter to run. And now you see the number of observations went down, of course, from 366 by 5, which are the number of NAs, to 361. Alternatively, we can also throw out all of the observations that have an NA in any column. How you would do that is you type again ozone and overwrite it with ozone, and then in the square brackets you type complete.cases, which selects only the observations that have a value in every field. And then in the brackets, regular brackets, you type the name of the data set. And after the closing bracket, you have to type a comma again to separate the row selection from the column selection. And we want to have all columns, so we're not going to type anything after the comma. And you can run the code with Command and Enter or Control and Enter if you're on Windows. And now you see, because we have so many observations with NAs, that only 203 observations are left. I don't know how you feel about it, but I think that is sort of not a satisfying result. So if we look back at our descriptive statistics, we see that particularly the second temperature reading here, that has a lot of missing values. So maybe it would be an idea to throw out this column and then run this complete cases command again, so that we keep all of the remaining columns, but this one we just discard completely because there are too many missing values to sort of reasonably get any information from it. The chance that we just screw up our data set by using it is maybe a bit too high. So what I'm going to do now is I'm going to run the code again from lines 4 and 6. And then I'm going to add a line of code here in between. And for the column selection, I want to use the code from a command from dplyr. So I'm going to type zone, and I'm going to use the pipe operator %greater %. And the command is select from dplyr, which you can use to select columns. And we simply type minus temp2. That throws away the column temp2. And I forgot I have to overwrite the ozone dataset with that. So we type ozone and then the arrow to the left to redefine it. And then ozone, the dataset name again, %greater %, select minus temp2. That throws away the column with the name temp2. And now we see we only have 12 variables. And now I'm going to show the summary statistics again. We see that the column is gone. And now I'm going to skip comment 25, line 25, and go immediately to 26 and apply the complete cases again. And now we see we still have 330 observations left. A moment ago it was, I think, 220 or so. So I think that is already a much better result. 330 of 366, that's maybe something that we can work with. Now, I think if you have enough data, then just throwing out all of the observations that have missing values, it's potentially a good way to deal with it, because then you can sort of be quite sure that the remaining data that you have, that it's of good quality, and you don't run the risk of sort of making false predictions because you dealt in a wrong way with missing data. You still run into the danger of making false predictions because you're missing information, of course, but I think throwing out observations with missing values is one of the more safe ways in general. However, maybe you think that 330 observations is already a bit low, and you still want to use the information from all observations that isn't missing. Then one way to deal with it would be, for example, to overwrite the missing values with the mean or the median of the remaining observations of the same column. And that is what we're going to do in the next step. So what I'm going to do is, once more, I'm going to rerun this code from line 4 to line 21. And now we have back the full data set except for the column temperature 2. And now what we will do is, for each column that has missing values, or actually for each column, we're going to replace all the missing values with the mean of the observations that aren't missing. And to automate it a little bit, I'm going to write a for loop that goes step by step over every column. Now, I do notice that, unfortunately, here for these weekday, day, and month columns, that we still have factor variables in here, which makes it a bit difficult to work with them. So in the first step, we have to change all of the columns to a numeric format. So how we do that is we type for, and then I have to assign a variable name, a temporary variable name for this loop, and I'm going to just use the classic I in, and then we will use the sequence along command, which basically goes in a sequence along the defined names, and then in the opening in the brackets we type call names of ozone, and then after we should here now have 3 closing brackets one for the for, one for the sequence along, and one for the call names, all get close. And then we type the swung brackets, and I'm going to make a new line to make it a bit more readable. We type ozone, and then 2 square brackets, which allows us to select a column with the name, and we type in I, which is the selection within the for loop. By the way, if you are not familiar with for loops, I have made a video on that as well, which you can look up in case you are feeling a bit uncomfortable with this technique yet. I think it's quite essential for any type of statistical programming. But moving along, we redefine that as s.numeric, opening bracket, s.character, opening bracket, ozone, and then in 2 square brackets, I again. So we have here 2 times the name of the data set, and then in 2 square brackets, we select the column name, and we redefine that as first as a character string and then as a numeric. This makes sure that everything gets converted properly. I'm going to run this command, and it goes without errors. That's great. And if I reload the data set, then I see that now this here is also all in numeric format. Excellent. So now we can go on with our main task, and I'm going to use another for loop. So it will be for, opening bracket, I in C. I'm going to create a vector. So 1 to n call ozone. And actually, I want to go one step back. Sorry for that. And I'm going to type ozone auric will be defined as ozone, so that afterwards we can look up which of the observations we're missing, and we can see if our procedure has been applied correctly. Okay, but going back to our for loop, so for I is the way that we move in a vector of 1 to the number of columns of the ozone data set, so that will be 12. We could, of course, also just type 12 here, but I find that this way it's a little bit more elegant. Okay, then we use the swung brackets again, and what we want to do is we start, of course, with the ozone data set, and we have to make a selection here. So we do the square brackets, and we want to select all the rows of column I that are missing. So it would be is.na, so we select missing values, and we want to select missing values in the ozone data set. So in this round brackets, we have to type ozone, but now we have to type square brackets again, because what we want is the missing values in the ozone data set in the column I. So we have here, we first do a column, a row selection in the square brackets, and we select the rows that are in NA in the ozone data set in the column I only. And then after that, after the isNA command, so the round closing bracket, we type comma, and then I again, because that is the column that we want to select. So we select the observations that are NA in the column I. And we overwrite that with the mean. So you could also use a different model here, but I'm going to overwrite with the mean. Off, and now it gets a bit complicated. I'm going to copy all of this part where we do the selection of the NA rows, and I'm going to copy it with Command and C, and paste it with Command and V. But now all we have to do is, in front of this is NA, we add an exclamation mark, which means that basically we use all the rows that are not NA, all the values that are not NA. And so of these values, all the rows of column I that are not NA, we take the mean. Okay, let's run this. And it runs without problems. And now I'm going to open here the ozone original data set. And we see here, for example, humidity is NA in the second row. And to go back to our descriptive statistics, the humidity had a mean of 58.48, which we see here. And if we go to the data set that we just worked on, we see here that humidity has been overwritten with 58.48. Also, we see that the temperature 1 is NA in the first row, and the mean of that is 61.91. And we see in our data set it's now 61.91. So we see that our operation was successful. And just to make sure, I'm going to run one more time this line 26 with the complete cases. And now if everything worked, there should be no single row that should be eliminated from our code. And indeed it wasn't. So this is how you can deal with missing values, two ways. One way is to eliminate the data that contains missing values. And the other way is to overwrite the missing values with information from the same column, from the observations that aren't missing, in this case with a mean. If you found this video helpful, then I would appreciate it if you gave it a thumbs up. And if you want to see some more advanced ways of dealing with missing values, such as, for example, taking into account the other columns, for example, giving this humidity a value dependent on the air pressure or the ozone level, I guess, yeah, the air pressure or the wind speed, then you might want to subscribe to the channel, because I have a video coming up on that very soon, where we dive into some more advanced techniques of dealing with missing values. All right, I hope I will see you there. I hope you liked the video. Thanks for watching. Have a great time, and bye-bye.